All right. Thank you so much, everyone, for joining me for this talk. I am super grateful that you guys decided to attend my talk on a Friday evening after lunchtime. That's like so much to handle. All right. So let's start with the talk. So basically, today I'm going to talk about neural style transfer, which is basically a transfer technique. We'll talk about what it actually is. It's kind of a computer vision problem to solve, and it has multiple creative applications as well as actually problem solving applications as well. So you all know what generative AI is. I uh, thought of including slides to kind of introduce what Gen AI is and how that is kind of changing everything that we are experiencing right now. But then I decided that it is something that everyone is kind of already aware of. So let's dive right into what neural style transfer is. Neural style transfer basically is a computer vision problem which kind of takes one image uh, and which takes two images as an input and takes the design and the visuals from the second image and the object and the idea and the basic essence of the first image and applies it onto that and creates a third image which is kind of a blend of those two in a very creative way. To make sense of all that I just said, let's see an example. So this is what I mean. We basically have a content image, which is the famous Mona Lisa image, and we have a style image. So this style is Cubist design, which is a medieval European design. And what we want to see as an output is Mona Lisa's image in Cubist design. So this is what it looks like. I hope you guys like it, but this is the best example I could find on the internet for this method. But this has a lot of applications specifically in the field of art, because there are a lot of times when we would want to kind of see a basic piece of art in different brush strokes or in different colors or in different design techniques, in different uh, you know uh, architecture patterns basically. One very famous application of this, like a real life application, is the mobile app Prisma. There was a huge trend of Prisma application, and it went super viral in 2020, I guess. And just to give you an example of what generative AI is capable of doing, so right now we have kind of reached the point where we cannot really distinguish between images that are created by AI and which are not created by AI. So just if you would like to take a guess, which one of these was created by AI? People who say first, this one. Okay. People who say second. Oh, okay. Sorry, but that one was created by AI. Okay. So yeah, the point is that now we have reached a point where it is kind of indistinguishable. Let's dive deeper into how does an NST actually work, and what is the basically science behind NST. So it employs a pre-trained convolutional neural network with added loss functions to transfer the style of the second image, which is the style image, into the content images object. Uh, let's see. What are CNNs for beginning? So let's start there. What are CNNs? What are convolutional neural networks, and how do they work? And then we can probably understand the concept of NST a little better. So CNNs are convolutional neural networks, and they are basically deep learning models which are primarily used for image analysis and processing. Although they have been applied to a bunch of other applications as well, but they are kind of used primarily in the multimedia space. They are designed to automatically adapt the spatial hierarchies of the data that they are fed on. Let's understand this, let's break this down a little simpler and understand this better. So imagine there is a picture and you want to, you feed an image into a computer and you want it to understand what the image is about. So there are multiple filters which act as detectives. These filters will look for specific image property. For example, there are filters that will look for colors in the image. There are filters that will look for edge detection, like edges and shapes and patterns. All these small filters make up basically the most atomic unit of this whole network. So let's just look at them as detectives. They are looking for a specific thing. They have a motive and they are looking for that thing. And then we have layers. So there are multiple layers, and these detectives work in layers. So the first one is the simplest layer, in which the detectives will look for just the colors in the image, or just the edges, or just the visual patterns, basically. Let's just say they are looking for colors in the very first image. In the second image, they'll look for edges. In the third image, they'll start getting more getting more complex, and they'll start looking for images, and then for maybe patterns, and then for objects. These layers can get as complicated as we want them to, and we can have as many of these layers and as many of these detective filters as we want them to. Then comes pooling. So sometimes we have an image that has a lot of style cues, that has a lot of things to work on, a lot of edges, a lot of maybe shapes or something, and not all of them are as important as others. So pooling is basically what defines the weightage for what exactly do we actually have to look into. Like if we are told that this is a directory of portraits, so we are not really focusing on, say, wall hangings, or what is what is the pattern of the background door or something. So that is where we define the weightage. That is where pooling comes in. Next, we have the fully connected layers. So fully connected layers are the end layers that will kind of be the boss and make the final decision. So if these small detectives or filters have found multiple clues that tell you that, okay, this is a picture of a cat. For example, they have found whiskers, they have found fur patterns, they have found sharp teeth or mustache or whatever. Then there will be this final end layer, which is trained on a lot of data. For example, open source COCO dataset or other object and image detection datasets. And this will make the final decision saying, okay, if this pattern goes above this much of accuracy, say 70%, then I will say that this is actually an image of a cat. And this fully connected layer is definitely changeable and configurable. You can add what accuracy do you want your model to kind of play with. Next, we have learning. So learning is a special concept about CNNs. The fact that these detectives or the whole architecture is learning from its mistakes. As we increase the amount of training data or the number of images that the model gets to look at, it will start learning more, and it will start getting better at the job that it is doing. So that was all about CNNs. Now let's see how NST makes use of CNNs. So as we saw that it takes two things as input. First is the content image. What it is looking for in the content image is the object detection part. So it is only looking at what is the object, what is the thing in the picture. It's not looking at the style or the brush strokes or the colors and all those things. In the style image, it is only looking for those things that it missed on the first one. That is, what colors are used, what are the design techniques used, what are the patterns that are used. And of course, like if we feed an image into a model, it does not make sense then and there like it does to us. It has to be converted into raw pixels, and then it has to be, these filters will detect the images and the patterns and the shapes, and that is how the model will work in the background. So yeah. And then the third one is the generated NST image, which is the final image that the model outputs, which, as we saw, is an amalgamation of both of these. So, all right. So what networks does NST needs? It basically needs a pre-trained feature extractor. If we just kind of recap what we just talked about, so between these two checkpoints, which is feeding the image into the model and the point where the model outputs the image, what we have in between is a very complex feature extractor, right? How we use this feature extractor is dependent on us. Like we choose to use CNNs with this, and we choose to kind of segregate what it will look for in the first image and what it will look for in the second image. But basically, the black box is a feature extractor, all in all. So that is what it is, the pre-trained feature extractor, and a style network. Style network as in the generative part of it, basically, which takes all the inputs from the feature extractor and applies it onto the output image and gives out the output image, basically. This is Prisma, the application that we just talked about in the beginning. So there is this specific embossed design that they have, and they'll take any picture and convert it into Prisma picture. Let's kind of recap on what the overview of what we kind of looked at and how does NST works with CNN networks. So the first is content and style. As we talked about, we need two things. We need the content, we need the style. The content is for image detection, object detection, getting the essence of what is the thing in the picture. And the style is more artistic side to it, like what are the colors, what are the brush strokes, what are the patterns, what is the basically visual feel of this whole artwork. And then we have neural networks. Neural networks, as we talked about, they are responsible for the object detection and the manipulation part. And next we have the comparison. So CNNs are basically responsible for taking the image and comparing both the images, like the style and the content image, and coming up with the exact things, like exact parameters for the style network to develop the output image. And next is actually creating the new image. So that part is taken care of by the style network that will take the content image and all the cues that it gathered from the the style image, and will apply it onto that and blurt out the output. And the magic of math, which is CNN, as we talked about, and iteration. So the computer repeats it as many times as it kind of as we want it to, just so we get the final output. We can stop at like 3 iterations for a rough, like first draft kind of output, or we can go till like 30 iterations and make it perfect over time. And then we have the result. So the result is basically the object in the first picture and the artistic style that you selected in the latter one. Let's talk a little bit about the implementations. So although art is a very big industry for this one, but it is also being used a lot in video and film production, where they kind of want to experiment a lot with, for example, a comic book or something that is not possible by editing. For example, Avengers has used NST in its filmography. And then photographers. So photographers use NST to play the same thing. They use it to play around with different artistic styles and give their images basically a unique look. And then design and branding. Again, architecture and interior design. This is also one of the key places where NST is currently being put into use, because as you can imagine, it would be super helpful in architecture planning and visualizing things in a different way that are not really created directly by the architect. And then fashion industry, content creation, medical imaging, VR, all these industries are where this has proven to be really useful. That was all. Thank you so much. Any questions?
Okay, so if there aren't... Oh,
sorry. I had a question. I was basically thinking about style image and result image. What about if we have like different resolutions of the images, right? For example, the content image is really high resolution or the style's smaller one. How it's connected. I understand that ideally it should be the same, right, to get the best results, but is it, yeah.
Yeah, thank you so much for asking that question. So basically, it would be helpful if they were the same resolution, but that generally not really depends, because we can also use vector images for the style image. We can also use images that are super high resolution or super low resolution. The idea is, as long as it is enough for these filters to detect what they are looking to detect, like edges and the brush strokes and the colors, it is enough. Also, for the style image, we do not really look into resolution as much as we want it to. We want the resolution to be higher for the content image than the style image, because that is where the object detection and the whole part is actually happening. For the style image, we can go with lower resolution ones as well. Thank you so much.
It's a question more about your opinion. In which cases a person, a designer, can be replaceable by AI in creating images, and if there are any cases to this point, why? How do you think why?
Yeah, so thanks for the question. So what I think is right now, with the state of AI that we are on, the clustering problems or the classification problems are much easier to solve, and we are far ahead with solving those problems than the generative part of those. Whether it's about writing content or creating images or movies or anything for that matter, it is still in its infancy stage, basically. So we are not there yet. If you have used Mid Journey, for example, and if you give an input saying, okay, I want a girl presenting in a room, in a conference room, this will nowhere be close to like this. It'll be super random, and there'll be a lot of, Gen AI anomalies that will be introduced in that. So we are nowhere as far as replacing the designers as of now, for sure. What I think is, as we are improving, there will certainly be a point where we can, right now, we can definitely take cues from it. Like if a person who is as non-creative as I am, I can definitely take cues from, I can put in a prompt in Mid Journey and it can tell me how I can think about the design at least. But yeah, to answer your questions, nowhere close to replacing designers for sure.